Assalamu alaikum students. Today's topic is going to be about equation of motion. What do we mean by equation of motion? That means the equations which are required for any moving body or to calculate any variables in a moving body is known as equation of motion. For that, there is three basic equations of motion for bodies moving in a uniform acceleration. These equations are related initial velocity, final velocity, acceleration, time, and distance covered by a moving body. Now, students, I want you to understand that whenever there's initial velocity, what does initial means? Initial means anything which is basically beginning or start, the velocity at the starting point. And final velocity, what it was the velocity of that object at the end. So whenever I say initial, it means velocity at the start, and whenever I say final velocity, we mean the velocity at the end. So it is represented as VI, the initial velocity, and final velocity is represented as VF, where acceleration is represented as A, time is simply represented as T, and distance covered, students, is represented by S. Now, to simplify the derivation of these equations, we assume that the motion is along a straight line. That means we are assuming that the body was moving in a straight line in a one dimension. Now, we consider only the magnitude of displacement, velocity, and acceleration. And we only are basically finding out the magnitude part of the displacement, velocity, and acceleration. And we will figure out the direction part later on. First equation of motion. Now, what is the first equation of motion? For that, let us assume that we have a sphere of body which is of yellow color. It has some initial velocity and it starts basically moving. Consider a body moving with initial velocity Vi in a straight line with a uniform acceleration. Uniform acceleration, students, mean the velocity is basically increasing but with the constant rate. That means uniform acceleration, it is increasing but with the constant rate. Its velocity becomes Vf after time t. Let me show you how this whole process begins and ends. So this is a mass and it has some initial velocity which we call Vi, and we have to move it from here till here. So if I move it from here to here, now it has some final velocity. From here it came over here, so it has some final velocity in time t second, and it covers a distance or displacement of s. Now we have to explain this whole part in form of a graph. The motion of a body is described by the speed time graph as shown in figure AB. Let's show the figure. This is a graph and here is the body at point A with the initial velocity Vi, and it will go to point B. Just like in the same case, this is the initial velocity, it has to come over here. So let us move it. So as it was moving from here till here, its velocity basically increased from initial velocity to final velocity. Now the slope of the line AB is acceleration A. That means this red line, this increase in velocity or change in velocity is known as acceleration. Now this line can also be represented as acceleration. That means the rate of change of velocity. That means the x-axis is basically representing the time part. So acceleration is there, and acceleration is there because the y-axis is representing the velocity and the x-axis is representing the time. Let me write down over here. This is representing the time and this is y-axis representing the velocity part. In this direction, increasing velocity in the time is representing in this direction. That means as the time passes, the body moves move with the increased velocity. The total distance covered by the body is shown by the shaded area under the line AB. That means this was a line AB. Now the whole area with blue color, the shaded part, is basically representing the distance covered by that body from here till here. Equation of motion can be obtained easily from this graph. Now we can obtain equation of motion from this whole graph. Here we have Vf, Vi, and this is time t from here to here. This is OD. Over here we have Vf, and that is why I'm removing all the writing part. So we have a body which is moving from initial velocity to final velocity in time t. So there was an increase. Speed time graph for motion of a body shown in figure. Slope of the line AB gives the acceleration of a of a body. That means A is basically represented as the acceleration of that body which was moving in the distance s in time t. The slope of line AB is equal to A, and that A is equal to BC divided by AC. Why do we say BC divided by AC? Because this is a slope, and we know that this is perpendicular and this is base. Okay, so the slope part can also be represented as tan. So tan can be represented as perpendicular over base. So over here we have this part which is line BC over here. This is representing the perpendicular part, and the line AC over here is representing the base part. So perpendicular over base will give us this slope which is represented by A. So A is equal to BC, which is this line, divided by AC, which is this line. But BC, we don't know the value of it basically. So how can we measure the value of this much part only? This much part only. We have the final velocity. The final velocity from 0 point is basically BD. The total distance is from here to here is BD, and the initial point is CD. So if we subtract these two segments, this one and this one, we will get this segment right here, which is known as BC. So BD, which is this line, the whole line, minus CD, which is this line, we will get this line, which is BC. And OD is the distance from the starting point till the end, OD. So this is the slope which we have got, which is representing the acceleration of that body which was moving from point A to point D. As BD is equal to VF, as we have told you that BD is equal to VF and CD is equal to VI, OD or AC, because they are both the same opposite side of a rectangle. So AC and OD are the same and they both represent the time t. So BC will be equal to BD minus CD is equal to VF minus VI. So over here we know that this much part, if we want to represent in the form of a value, so we have to subtract value of VF by VI. So this much part can be represented as VF minus VI. So let us write it down. Hence, A is equal to VF minus VI divided by T. We will prove this part because we know that this much part is equal to VF minus VI, VF minus VI, and this much part is equal to T. So again, we have perpendicular over base, same over here, because the BC is equal to VF over BI and T is equal to OD or AC. So we have both these values now, and whenever we divide them with each other, we'll get a slope from a trigonometric formula which is equal to tan theta, which is representing the slope. Now in this case, we will represent this line as VF minus VI, which is represented in purple color. Now, this VF minus VI divided by T, if the T goes on to the other side, like over here, if we take the T to the other side, it is dividing over here, it will multiply over here. The same equation can be written as VF minus VI is equal to AT. That means instead of writing VF minus VI over here, we can write down the gain in the speed, which is represented by AT. That means this part is being represented over here, this much part right here. So this line can also be represented as AT. So this line is VF minus VI, and this is also called AT. That means acceleration into time. Now we have this much distance, which is the speed gain. We have this much distance AC, which is the time taken by that body. And this whole part can be rearranged to form the first equation of motion, which is basically representing the acceleration. The same equation can be rearranged and can be written as VF is equal to VI plus AT. This is the first equation of motion. Now, we can also differentiate these two areas upon their shape. Now, as you can see over here, this is area of a triangle and this is an area of a rectangle. What is the area or formula for area of a rectangle or a triangle? Half into base into height. So half we have already. Base is this much, which is equal to T, OD, and AT was the height over here. AT was the height as shown over here. So if we put that, we have half into base into height. Similarly, in this case, area for rectangle, which is base into height. So this is base basically, and this VI, this much distance, is the height part. So height into base is known as area of a rectangle, and in this diagram VI is the height and OD is representing the time, which is the base. So by this way we can basically calculate the whole distance traveled by the body moving from point A to point B in a linear position, and by that we figured out the first equation of motion, where VF is the final velocity, VI is the initial velocity, A is the acceleration, and T is the time. Now coming on towards the second equation of motion, in the speed time graph as shown in figure, again the process is same. The body covers distance from A to B. We have an acceleration, we found out the acceleration, we covered the distance also, and there is point F from which the body has reached, and VI from which the body has started, and we have a distance VF minus VI. We figured out that it is equal to AT, and we figured out that the areas of the two shapes are basically representing the distance within the distance of point A to point B under the line. The total distance as traveled by the body is equal to the total area OA BD under the graph. That means this OA, B and D, this whole blue color, which is light and dark blue, is basically representing the distance traveled by the body from point A to point B. So the total distance, that means the distance of the rectangular area, in the rectangular area as well as in the area of a triangle, it is OA into D, which is VI into D, like over here. height into base, and in this case the area for triangle is AC into BC. That means half, which is the formula. T is the base and AT is the height right over here. So if we gather them all, the area of a triangle, this one, and the area of a rectangle, this one, if we add them up, we will get the total distance traveled by the body from point A to point B. Let us basically show it in a vector form. So these are the shapes: area of a triangle plus area of a rectangle. If we are adding them up, putting the values in the above equation, so area for rectangle is Vi into T, which was over here. We put the value of Vi into T of the rectangle over here, and this was equal to the total distance, and the area of a triangle is also added up, and we are putting it over here. So what do we get? We get S is equal to Vi into T plus half AT square. So if we add them up, we will get the total area or total distance covered by the body from point A to point B, or the total distance, which is equal to S is equal to Vi, where Vi is the initial velocity, T is the time taken by that body, A is the acceleration, and T is again the time taken by that body. So this equation is the second equation of motion. Moving on towards the third equation of motion, again the process is the same. The body moved from point A to point B. There's an acceleration, which is represented by a slope. There's the distance covered, which is represented by two shapes. One is triangular or right angle triangle, and the other one is rectangle. We figured out the points A, B, C, D, O, and we figured out the difference in velocity Vi and Vf, and we found out the gain in the first equation of motion. Now in the third equation of motion, we are going to learn about a different form of finding out the same distance which was traveled from point A to point B. The total distance traveled by the body is given by the total area OABD under the graph. Now we again have the total distance, but now we are not looking in the same way. We are not looking at it as a triangle or rectangle or a right angle triangle. We are looking at it as a trapezium. Basically, we have gathered up the rectangle and the right angle triangle, and it is a new shape which is known as trapezium. But the concept or the motion of the body is same in a straight line. So the area for trapezium is A plus B divided by 2 and H, where A is one side of the trapezium, B is the other side of the trapezium, and H is the height of that trapezium. So let us mention it. So this much part OA is basically representing the A part, BD is representing the D part, and H is representing by the T part. So T is represented by H over here. So the total area of OABD is equal to the total distance traveled by that body, which is equal to OA, which is this part, and DD, which is this much line, divided by 2, multiply by OD, that means the height of that trapezium, which is represented by H. Now in this case, we are going to represent the equation of motion. The same thing can be written as, when we take the 2 to the other side, it will be 2S is equal to OA plus BD into OD. Multiplying both sides by BC divided by OD, we get, because we know that from first equation of motion that BC over OD is equal to A. From first equation of motion, we got this one, because the height of the triangle, this much part is BC, divided by OD. You can say OD or AC, it's the same thing. So we'll get the slope. So we are multiplying this equation by BC over OD. 2S into BC over OD is equal to OA plus BD into OD plus BC over OD. Now we have a formula. Now we can cancel out this OD with this OD, and we can get a value like this, and we can get a value after cancelling these ODs. 2S into BC over OD is equal to OA plus BD plus BC. That means this BC will be left behind, and we will basically solve it like putting values in the above equation, because we know that BC over OD is equal to A, right over here, and OA plus BD into BC. Let us put the values. So 2S is written as it is. BC over OD is A. OA plus BD. OA plus BD is basically the total distance traveled by the body. Let's say OA is from here to here, and BD is basically the total distance from here to here. So we are adding these two up, the sum of the two triangles. That means OA was A, and BD was this much part. So putting in the values, so VF is BD, and OA is the VF part, and the last part is BC. And as we know that this much part BC is basically figured out as VF minus VI. So we are putting that in this equation, the values of BC. Now if we put it in the values, we'll get, and we have the formula now, which is represented by A plus B into A minus B. As you know that A square minus B square is equal to A plus B into A minus B. So if we multiply these two values, we get A square minus B square. The same formula can be applied over here, because there is one plus over here between the two terms and one minus over here between the two terms. So if we multiply, we'll get 2AS is equal to VF square minus VI square. This is the equation of motion. Inshallah, hope you understand this topic. Inshallah, we'll meet again. Okay, Allah Hafiz.